Okay, so let's move on to talk about the basic syntax of ASTRA and look at how it maps onto the basic agent speak syntax. So ASTRA, as I mentioned in the previous presentation, is designed to be close in syntactic style to Java. ASTRA programs are written in files that are text files, and they must have a .astra extension, and each file contains exactly one agent class, which is specified using the agent keyword. Now, this is a little different to ASTRA in that ASTRA allows you to define, for example, inner classes, static inner classes, anonymous classes. We don't allow any of that. Within ASTRA, every agent class is in a separate file, and every agent class is defined by an agent keyword, and the name of the file must match the name of the class. So if we're going to have an agent class called tower class, which is going to be, as you can guess, an implementation of our tower world agent, then that tower agent class should be in the tower.astra file. It should be in the tower.astra file. Okay, we declare a class saying agent tower, and again, case matters, and it's got to be exactly the same as file name, and then a set of curly braces, curly brackets, and the code goes inside the curly brackets. So it's kind of similar to the way Java defines a class, but there's also no modifiers like public and private, and it's a much simpler implementation. Now, the first thing that you often need to put inside your agent classes is that you need to define what we term an ontology, or a set of types. So if you remember back, one of the things we did when we sort of started looking at, for example, Tower World or the tic-tac-toe or the light switches, we developed a set of predicates to model that world. Well, in ASTRA, you actually have to declare those predicates in advance as part of the program. So we have a types keyword that has an identifier. So this is the tower ontology. It's ontology with a little o here. It's not the same as some of the more complex definitions of ontologies, but basically it's a list of predicates that you're going to use in your code. So here's a block predicate with type string. You've got a table type string. On predicate takes two strings. Free takes a string, and holding takes a string. You'll notice the string, it appears. This is part of the static typing that is used by ASTRA. So a block can only take a string. The block predicate will only accept string arguments. Okay, it won't accept integer arguments or anything like that. Okay, so you have to define this, and suppose this is really linked to the static initialization stuff, the static initialization that I'm talking about in one of the later presentations, but I kind of have to drop it in here because you can't write an agent program without defining a set of types. So your agent program has the agent keyword, has the name of the agent class, curly brackets. Inside those curly brackets you write your ontology. You can have multiple type statements per agent. And in fact, one of the reasons why I support multiple inheritance is that you can create some code, create some agent classes that are just types. They're shared ontologies, and then you can implement those. You can then integrate those ontologies into different agent implementations. But we'll come back to that later on. The next thing is the initial state. So the initial state is defined through the initial keyword. The initial state can be a comma delimited list of predicates, or it can be an individual predicate, just for its readability. So here we're defining the initial state of a tower world that has a state of tower world that has 4 blocks, and so on. Okay. You can also declare initial goal. So you talked in the last lab about the tower goal with A, B, and C to build a tower of 3 blocks. Well, here's an example of the tower goal in ASTRA. So one thing to point out, if you were to copy and paste this code directly into a text file and save it as tower.astra, this code wouldn't compile because PowerPoint has the habit of making the quotation marks into these fancy angle quotation marks, and these are not valid quotation marks for an ASTRA program. They have to be basically shift and 2 or wherever it is on your keyboard, but they have to be the standard double quote that's used in the same way that if you copied a Java program from PowerPoint in, you might get the same problem. So this won't compile, but if you change the quotation marks, it will compile. Once you've got your initial state and you've got your types, you can then write rules. So here's an example of the rule for picking up some block X. So you have the goal to be holding X. Notice you're going to have to define the type. If you're not holding some block Y, and X is free, and X is on some block Z, then you can pick X up by adding the belief holding Y. Oops, this is a mistake. Adding the belief holding X. I don't know how I got that. Removing the belief that X is free and removing the belief that X is on Z. Okay, so this is like the rules that we've done in the last couple of weeks. You can introduce inference rules like we did within the modeling scenarios we've done before. So you use the inference keyword to define inference rule, and the rule is this follows the left hand side follows from the right hand side. So X is free if there is no Y on X and you're not holding X. Okay, that obviously has an impact that we're able to modify remove one of the belief remove statements from the implementation of the rule. We're able to get rid of the belief minus free X and just do holding plus holding again, plus holding X and minus on X, Z. Back to play from current slide. Okay, so that is it from this. I suppose this gives you the ability to write. You can essentially copy your implementation of Tower World or the light switch world into here, and you could compile the program. I suppose the problem is there's not much you can do in this program. I mean, firstly, from the state of the Tower World, you can implement Tower World as a purely mental agent, but there's no way for you to see the state of the agent, and ASTRA contains no implemented statement to print out state. So you can't say display state, and it's not a keyword displaying the state or outputting the state. It's not a core action supported by agent speak, or say by ASTRA. Just in the same way, it's not a core action supported by agent speak. In the next section, I'll explain a little bit how we can build and use sort of custom APIs within ASTRA to allow us to extend the functionality to give us the ability to print things out and to do debugging and things like that.